Today we're going to be talking about quantum numbers and specifically the n quantum number or the principal quantum number. So this can be a really intimidating topic for a lot of general chemistry students, just because quantum seems like a very complex word, and this topic can be a little bit shaky. But we are going to just break it down and talk about it in plain language and get to the bottom of it, right? So the n principal quantum number has a lot to do with the energy level of the electrons. So in our atom, we have our positively charged nucleus. In here, let me get my laser tool here. So we have our positively charged nucleus, and then we have our negatively charged electrons orbiting around it, right? So when we talk about high energy and low energy, let's think about two different situations here. So in scenario one, we have a situation where the proton and the electron are separated by a really large distance. So we know that positive and negative charges are attracted to each other. So this isn't really the ideal state, right? They're far away. They would like to be closer together. So this is going to be a high energy state. It's kind of like if someone were to pull the string back on a bow, right? To release an arrow. We're storing energy by separating them by a larger distance. Now, in scenario two, we have the proton and electron, and they're a little closer together now. So this is where they would like to be because they're attracted to each other to get closer. So this is going to be a lower energy state. So keep that in mind. High distance, high energy; low distance, low energy. All right, so let's get back to the whole quantum number thing. So the n quantum number could be 1, 2, 3, 4, 5, 6, all depending on where our electron's at, right? So we know that there's a higher distance, there's a higher energy. That's the same for n values. So when there's a higher n value, there's going to be a higher energy. And that's just because smaller n values mean that the electrons are closer to the nucleus, and higher n values mean that they're further away. So in this example, in the Bohr model, which is just a model of an atom, we have our positive nucleus in the center, and electrons that are in the n equals 1 level are very close to the nucleus, you can see. So those energy levels of those electrons are going to be much lower than the further out electrons. So moving out, we have electrons in the n equals 2 energy level, and the distance between those and the nucleus is a little bit more, so those are going to be a little bit higher in energy. Moving out to the n equals 3 level, the distance is even greater. This is massive distance compared to 1 or 2, so these are going to be really high energy